The idea in this video is to make this transformer work in place of the original type. It's almost identical, other than the pinout being different. The inductances, they're more or less the same on the winding from the horizontal output transistor. There's also a feedback winding there. The EHT winding and focus G2 setup is that's the same. This transformer's out of a Mark II Philips. The original that we're working on is from a Mark I. So the only difference that I found other than the pinout is the feedback for the horizontal pulses. On the original, there's a center tap winding. On the Mark II, there isn't. The center tap, one side goes to ground, and the other side goes to wherever it needs to go to, and the input if the pulses come in, whatever. That's the only difference. You can see I've got some PC board here. The plan is to hook it up using some flying leads. If I can make it work pretty reliably and safely, then I'll make a nice little safe adapter using some PC board. I've got these here. Now, these are tuning capacitors. We've got some tuning caps here. And because it's a circuit which is fixed tuned to the transformer, it might not work to the best it can possibly be. So for example, you might have not enough width in a picture, the pulses might not be strong enough. Sorry, my cat is crying, sorry about that. Fixed tune circuit. So I've got some tuning capacitors here. I doubt that it's going to be a problem because the inductances of the windings we're concerned about are more or less the same. However, I've got them here just in case. We might have issues with, for example, the heater winding or the EHT not being enough. My main concern personally is the horizontal pulses not being strong enough, because the peak to peak voltage, according to the diagram I've looked at, is slightly higher than from what the schematic is calling for. It basically just means if a lower pulse is going into a transformer that wants higher pulses, the pulses aren't going to be that strong to drive the transformer or something like that. Yes, basically. So I'm going to do that now. I've had a couple of people ask me, well, what's the point? Why am I doing this? Why don't I just order the part? Well, the transformer costs 50 quid. Plus postage on that website. Sometimes the replacement transformers aren't reliable, or they're not the perfect match, so I'm going to need to do modifications anyway to make the replacement part work. For liability reasons, it's one of these things that's sort of frowned upon. It's not a major modification, I wouldn't call it that anyway, but a couple of people asked or have stated, well, it doesn't seem very safe. Think about it this way, right? Changing components in a monitor, if I change a cap and that cap, whilst the capacitance is the same, the ESR values might not be identical than what the original schematic had called for. They're not dropping, they're dropping replacements because they work, but they're not exactly the same. Or for example, if I was to change a resistor, a carbon type for I don't know, metallized resistor or something similar, well, that's the schematic didn't call for that. You can say, well, something like that may potentially cause a fire. Well, I highly doubt that. The line time base isn't that powerful. There's a handful of pico fuses covering the line drive section, as well as the main incoming fuse anyway, on the power supply and also in the plug. If smoke did erupt from this, I mean, it would be pretty interesting, to be honest. The idea is if I can't make it work reliably or at all or safely, then I'm just going to, this repair will be scrapped. I say that honestly. The guy basically said, look, if you can't make it work, you can just take it on as spares or whatever. I mean, I'm always running out of spares for these types of monitors, so it's nice. It would be nice to have another spare board, but really I'm running out of Mark 1 line transformers. So I mean, these delay lines, also they tend to go as well, and finicky ICs and whatever, these potentiometers, but also the power switches. You know, one can say, oh, well, I've bypassed the power switch. Well, that it doesn't meet the requirements of the manufacturer's specification. Surely your insurance wouldn't cover that. Well, this is why it's really important to have a customer agreement contract. So you can outline all of these things. And if they agree to it, if they sign it, then you're covered by your contract. You know, you need to set these things out fairly explicitly, because we're working with old equipment. It might not always be reliable, and you have to do everything in your power to ensure that the work you do on this stuff is safe and you don't inflict risk on someone else. So with that being said, the first test I'm going to do is I'm just going to wire it up on long leads. Really, it's a bad idea, loads of potentials flying about, but I'm going to be setting up a safe environment here, and all we're trying to do is just seeing. We'll connect the yoke. We're not going to connect the EHT up, but I am going to measure the EHT. We're not connecting the focus or G2 supply. The idea is, if the line time base runs with the transformer in, and it would be just over half the EHT, because it won't be smoothed by a capacitor. If I can get around, I don't know what it'd be, 12, 15 kilovolts, whatever, just over half of 23, I think it's supposed to be 23,000 volts, then we're all right. Now, then the next thing would be testing it with the CRT installed and G2 and focus. And if we can get line lock, I mean, we could probably try and get line lock without those things connected with the oscilloscope. We can just measure the sync pulses. It's more faff to set that up than it is to just hook up, you know. So first things first, let's connect the replacement transformer on some flying leads. If this all goes well, then perfect, and I can make a nice little adapter using some PC board and a couple of screws or nylon screws or something. It's going to be an interesting one. I'll see you all in a bit. Okay, well, phase one is done. It was a bit fiddly. I did poke myself a couple of times, my fingers, with those little wires, but I've got those attached now. Phase two will be soldering it onto the board with the correct places. So yes, I'm just going to take 5 minutes, have a coffee and just relax a little bit, and then I'll look at the diagram and just start mapping this stuff out. Most important thing is doing the winding for the line output transistor, horizontal output transistor, EHT and pulses. We don't have to do heaters just yet. I don't think it corresponds with anything. I'll put those in. And then what we can do is power this on and see if we get any EHT. Okay, this is the first genuine test. So I've wired it up, right? I've seriously never tested this before. If it goes bang, I'm just using my own power supply for this. This is one of the ones I had in my spares box. Here we go. I just heard EHT. I think that's 10 kilovolts. Wow, really? No, that's 10 kilovolts without the scan coils connected and the EHT connected to the tube, which is obviously smoothing it. So, wow, okay. First things first, now let's connect the CRT up, get our RFs done, connect our scan coils, and I have to do focus and G2, which I think I'm just going to bodge in just very quickly, and we'll see if this works. And you know, if it does, then it means it is a drop-in replacement. I still can't, we're halfway there. Well, we're all hooked up. The only thing I'm going to do is get something to rest the board on. I don't want these wires, because they're quite thin insulation. I don't want anything shorting over or flashing over or anything, so I'm just going to get something to rest the PCB on. Okay, so the PCB is just flapping in the breeze. Let's see if this works. I heard the tube come up. Come on. Give us something good. Do you see that? Vertical holds all over the place. I don't want to get shocked. We got flying EHT all over the place. Let's see if I can get some video on the screen, eh? Right, so we need to turn on me pattern generator. Come on. Oh, you have to press like a million buttons. Nope. Ah! We got a lock. You see the lines have locked. So we've got video now. What's going on? Set this to our usual picture. Let's see what's going on. Is it because our brightness and stuff is turned down? Look, our focus potential's just floating in the breeze, so let's be quite sensible with it. Don't want to touch that. I'm failing to see where the picture's gone, because I can't. Oh, no picture now. I'm just going to mess with this and see if I can get the picture.